Good morning, everyone. In the previous class, you saw the working of neural network, entire working of neural network for one application, that is digit recognition from a given input image. So that was the actual working of neural network. Uh, it gives like in the previous class, you saw just complete whole from beginning to the end. How does a neural network work? Uh, but its internal organization was not there. Today we shall see from the scratch what are the basics of neural network, how you are going to start building the neural network and applications of neural network, uh, the actual problem where you can use a neural network as solution. Is it clear? So neural network, name itself indicates neural network. Uh, it's always our aim to replicate the functionality of ourselves. Okay? We always try to do the things that we can do through the computer, right? And one of the most powerful organ of human beings are brain. So from very long, people are trying to copy the operations of the brain or implement or try to simulate the working of the brain. The brain is very powerful, and the most important component in the brain is neuron. A neuron is actually responsible for each and every action brain does. So, how many neurons are there in the brain? In brain, there are actually billions of neurons that are present, and each neuron are interconnected with other neurons. So you can't even imagine how complex that structure is, our brain structure. Mimicking the brain operation, it is not at all a simple task, and so far none has achieved it. Okay, we are so much advanced in technology, but brain is one thing. Till date, people have not even studied the entire functionality of brain because that structure itself is so complex. Uh, See, neurons, small neurons, billions of neurons, and they are interconnected with each other. They send signals to each other. Okay, you can't imagine which neuron is doing what task. Okay, parallel. Our brain does everything parallelly. See, it is one of the best example for parallel computing. Multiprocessor, multitasking, everything it does. Uh, so, like, if we see something, an image, or if you see a person, it hardly takes fraction of seconds to identify who it is. Okay, to recognize an object, whatever it is, we our brain does it so fast. Input signal goes from the eyes to the brain, and it will do the processing, and it will recognize what object it is, who that person is. Okay, everything happens in a fraction of seconds. For the same thing, if you design a system, it takes a lot of time. Okay, image recognition. If you have to provide one image as input, it will recognize, it will process, it will run some algorithm on it. Okay, you need, if your processor is very good, if you have graphical processor card, all those things, GPUs are there, then you will get fast results. Otherwise, results are very slow. So what like from long time people are saying like, okay, brain is very powerful. We have to write the program such that we can implement almost working of the brain. But it is not possible. It is never possible. It's not an easy task. So neuron is the basic component in the brain, okay, which is very responsible for all these things. Uh, when we say artificial neural network, so scientists thought that first thing is we have to design the neuron. See, one neuron is almost equals one processor. Okay? So many things it does. And millions of neurons are interconnected, millions, billions of neurons. So in that way, if you are asked to imitate the brain, then you have to interconnect thousands of computers, processors, which will do the processing, which is physically completely impossible. Okay, to interconnect all the processor and make it work parallelly. But still, we have to like we need that neuron. So then we came up with a concept, one unit, basic unit, which will almost do the same kind of task like neuron. Okay, that is required. So from there, artificial neural network started evolving. Okay, in artificial neural network, that basic computing unit we call it as perceptron. Same, the thing that is present in brain is neuron. Similarly, we want to do something similar. We want a unit which can be considered as neuron. So uh, a unit was designed, which was called as perceptron. Okay, perceptron. So, like you can see, uh, we shall start with what is perceptron. What are the things it does? We shall see that. Yeah, these are the things I explained. Number of neurons, 10 to the power of 10 connections per neuron. These many interconnections will be there. It recognizes any image 0.1 second. Okay, parallel computing. So these are the actual human neurons. And if you want to do something like that, properties of artificial neural network means that perceptron unit, whatever I am saying, that one. Okay, threshold switching units, weighted interconnection. I will explain what is weighted. Parallel, it has to be. Okay, training the weights. That is a important thing in neural network. Okay, first neural network example, Alvin, which is a self-driving concept car. You can see here, yesterday also you saw neural network structure. There was input unit and hidden unit and then output units. Okay, we call this as input layer, hidden layer, and output layer. Any neural network you take, there will be one input layer and output layer. Also one, uh, okay, input layer and output layer will be only one layer. Hidden layers, it can be any number of hidden layers in between input and output layer. Okay, you can see here the sensors which give the input to the program, those will become the input units here. Okay, signals are provided by the sensors, that is input unit, and these inputs are provided to the hidden layer, and it will do the processing, and it will pass the output to the output layer, where it will instruct whether car has to go straight or it has to take slight left or slight right, hard left or hard right. Okay, 30 output units. This was one example wherein they used a neural network to drive the car without driver. Okay. As I said, neural network structure means it will have input units, hidden unit, and output units. Okay, hidden layer, it may be one layer, two layer. It depends on the how complex your problem is. So it varies. Input layers will be there, output layers will be there, hidden layers will be there. In any neural network you are designing, these things will be there. Okay, this is one example. And next, one more example is face recognition. Okay, face recognition, you can see here. Input units. Input is a small image. Image means it will have pixels, 30 into 32 pixels. That is, okay, 30 into 32 pixels means almost 900 input units. Okay, this is the input image, and some hidden units are there. And then output, like if you provide an image as the input, output is it will say whether a person is seeing left, straight, right, or up. Okay, it will give the results like this. If you give the image as an input, uh, again, one more example wherein neural network was used. Okay, if you you can see this link here. If you go to this link, you can see uh, input is nothing but a small image. If you provide this image as an input, our system will say whether the person is in straight, left, right, or up. Okay, that is one more example. Okay, weights, epoch, and all, we will see that later. We'll see what they are. So, yeah, some of the design issues in these two is input encoding. Again, these things you'll understand once we start learning the neural network. Next question is, say we have so many algorithms, categories of algorithms in machine learning. Uh, Whenever you are given a task to design any system using machine learning, first thing is you have to think which algorithm you are going to use, which concept you will implement. Like, are you going to implement a decision tree, neural network, or KNN, K-means, supervised learning algorithm, or unsupervised learning algorithm, or reinforcement kind of algorithm? See, so many categories of algorithms are there. Whenever you are given a task, okay, now you are doing the project, okay. If you have taken any machine learning area, then you have to think, okay, concept is okay, you have some task at hand, but the thing is you must decide which algorithm you are going to use. So when to consider neural network as an option? Input is high dimensional, discrete, or real value. Okay, input is high dimension. As we said in the previous two cases, you can see we were receiving the input from the sensors. Okay, it's a huge input, and image recognition also. So many pixels will be there. It was just an example of 30 by 32 pixel. Our images almost it will be 400 by 500 or 500 by 600. Very huge image sizes. If you are doing image recognition, input is a high dimensional data. Okay, so in that cases you can consider neural network. Input is very huge. Okay, that data is huge. Discrete. Okay, discrete means continuous data. Now discrete means, okay, one or two or three classes. Real valued means continuous data. Input may be discrete or real valued, whatever it is, you may consider neural network as an option. Output, again, output may be either discrete or real valued. For both, it works very well. Okay, whereas decision tree, when you talk about decision tree are not recommended for real valued input and real valued output. Okay, in those cases, we should not consider decision tree. But neural network, you can consider for both the cases. Output, again, output is a vector of values. Output is not just one value or two value, it's a vector of values. Then in these situations also you can consider neural network. And you know that your data is noisy. It is not completely accurate data or clean data. If you have those kind of doubts, then you can definitely adopt neural network. And again, if target function is unknown, then also we can prefer neural network. And the final thing is, final point, human readability of result is unimportant. See, neural network, when you implement neural network, you'll start getting the results, but you will never understand how you are getting that results. The neural network itself is so complex. It is so complex. Once you implement it and once you start getting the results, if someone asks you how you are getting the results, explain what is going on, it is highly impossible to explain, understand the weights or structure of the neural network. Okay, implementation is also complicated. Once implemented, once you start getting the result, understanding the background is itself is very complicated. If that is not so important, okay, if the understanding is not that important, then you can use neural network. See, if we are just result oriented, not the procedure, how we got this, how we arrived at something, if that is not that important, then we can use neural network. And one more issue with neural network is it takes lot of time for training. Okay, you should have that much of processing power, because it will go weight adjustment, we say. Okay, weights are very important in neural network. When we talk about weight adjustment, it takes thousands of iterations. So it will do processing a lot. If the training time is limited, then definitely we should never opt for neural network. Or if your processor is slow, in those cases also, uh, neural network is not recommended. Okay, it takes uh, heavy processing power. For that reason, if that is not the constraint, then neural network is the best option for implementation. Okay. So, neurons, we were talking about neurons in the human brains. We need to mimic the operations of the neurons, but exactly we can't do that. So, a one more unit that was designed in artificial neural network, we call it as perceptron. Okay, perceptron unit. So this is that perceptron. See, this mark indicates summation. Okay, summation. Summation of what? See, this is a perceptron unit. Okay, here summation is there. What does summation indicate? So this unit receives inputs x1, x2. See, from the first class, I'm telling you, whenever you see x, x is nothing but input. Okay, x, wherever you see x, x is an input. X1, x2, x3 up to xn. So these are the inputs for our perceptron unit. Okay, various inputs are there. We'll provide these inputs to the perceptron unit. Along with the inputs, you can also see W1, W2, and Wn. So for these inputs, we'll add some weights. Okay, for these inputs, we'll add some weights and then we'll provide it to the perceptron unit. Okay, and this is summation is there means it is nothing but the combination of summation of input into weights. Okay, output is nothing but summation of x1 into w1 plus x2 into w2 plus x3 into w3, like that. It will add up all the weight and input combination, and then we'll keep a threshold. If this sum, you can see that if the sum is greater than or equal to 0, I will say the output as 1. Otherwise, we'll say that output is minus 1. Output of this unit is nothing but the summation of combination of input and weights. If this sum is greater than or equal to 0, we'll consider the output as 1. Otherwise, we'll consider it as minus 1. Output of the perceptron unit. Is it clear? And this X naught and W naught, it's a bias. Okay. Uh, in the first class, you saw what is bias, why we need bias. Again, with example, I will explain you what is this bias. X naught is one more input and it is always 1. W naught is some weight which we call it as bias. Is it clear? Perceptron unit, it will receive the input, various inputs, x1, x2, input vector it will take and will add the weights. Okay. So perceptron is nothing but summation of, it will do the linear addition. Okay. And if the result is greater than 0, we'll consider the output as 1. Otherwise, output is minus 1. You can see here, this is the threshold. Output is nothing but 1 if the summation of wi and xi greater than or equal to 0, minus 1 otherwise. That's the output of perceptron unit. Okay. So this is the output of perceptron unit. So like this is just a simple unit. Okay. While explaining the example, I will tell you How this unit will help us designing the neural network. So perceptron unit, you should keep in mind what it does. Okay, it takes input and we'll add the weights. Input output is nothing but if the weight and input combination, if you sum it up and if it is greater than or equal to 0, output is 1. If it is less than or equal to 0, output is -1. Is it clear? So this is the perceptron unit. Have you understood? So obviously, next question is weights. What is the weight? What do you mean by input? You understand input to our network. Okay. If it is image recognition, pixels are the input. If it is self-driving car, sensor values are the input. So input, you know that is the input, and weights, you know. And the question is, what is the weights? How you are going to decide what should be the weight? In neural network, we in the first module also we came across weights. At that time, I told you like we should. I'll explain about the weights in the neural network chapter. See, this is very important in any neural network. When we talk about neural network, important thing is weights. How we are going to assign the weights to the input. Okay, weighted input. We call itself as weighted input. So, what is W1? What is W2? What is W0? Who will decide what weight to be added to each and every input? See, that is where it makes things complicated. Okay, weights will decide which input is very prominent. So that input will be given higher weights. The like pixel, which is very important, for that we'll add more weights. In the digit recognition, you can see with the curve of the 8, okay, the straight line. Only those part of the pixels are very important. So for that, we'll add more weights. But how? How we are going to add weights or find out what weights should be added to the inputs. So this is where actual algorithms will come into picture. To calculate weights itself in the network, to update the weights, we have various algorithms. When we talk about neural network algorithms, each and every algorithm is concentrating about the weight update. Is it clear? In neural network, input we know, output also we know that what we are expecting. The important thing is weight update. How you are going to update the weights, how you are going to assign the weights to the inputs. If those weights are not correct, how we have to update it. So that is the important task in any neural network. Okay. Uh, and again, perceptron unit, like so this was first designed like you can see here in 1962 itself. This perceptron unit was concept was proposed, but this perceptron unit will work only on certain kind of problems. Okay, those problems we call it as linearly separable problems. Okay, you can see here are two diagrams A and B. A, we call it as linearly separable problem. B is non-linearly separable problems. So what do you mean by that? You can see here, if I draw a line, all positive cases are at one side and all negative cases are at another side. So these kind, like if you are doing a classification problem where yes or no's are there, two class or three class classification. And if you draw one linear line, all positive cases are at one end and all negative cases are at another end. So this is an example for linearly separable problem. Okay, if this is your task, then you make use of perceptron unit, and you can see the second diagram here. Wherever you draw one line, plus and minus are at one end, and they are not together. Only positive cases and only negative cases are not together. Is it clear? They are like they are mixing up. So these are non-linearly separable problems. If your problem is linearly separable, then only you can use perceptron unit. If it is a non-linearly separable problems, we cannot use a perceptron unit. Perceptron unit is also called as linear unit, okay? Because of this reason, linear line, linearly separable problem. So it's a linear unit. If you have non-linearly separable problem, then that perceptron unit is again modified. We call it as sigmoid unit. Okay, so we'll study sigmoid unit instead of perceptron unit in neural network. Most of the cases we'll use sigmoid unit itself. So in exam, straight away they may ask you to explain perceptron, structure of the perceptron, okay, or they may ask you to explain linearly separable and non-linearly separable means what are those things, and or they may even ask explain sigmoid unit. What is sigmoid unit? That we shall see in the next upcoming slides. Is it clear? If your problem is non-linearly separable, then we'll go for sigmoid unit. If it is linearly separable, we'll use perceptron. Have you understood? So most of the cases when we say neural network, we are addressing non-linear problem itself. So we are going to use sigmoid unit itself. When we talk about any example, all are non-linearly real world examples means they are non-linear problems itself. So in every way we are going to use sigmoid unit. So you need to understand what is sigmoid unit, how does it work. Okay, so this is sigmoid unit, all right. That was perceptron unit, and this is sigmoid unit. We shall come to this later, like in the upcoming slides we shall see what is linear perceptron sigmoid unit. And yeah, and gate you can implement using perceptron. Okay, for that, what is the weight? See, AND gate, two input AND gate means x1 and x2. Its input can be either 0 0, 0 1, 1 0, 1 1, x1 x2. Okay, those are the values of the inputs, possible values for input. Output, you know, if it is 0 0, output should be 0, 1 0 means 0, 0 1 means 0. AND gate, we are trying to implement AND gate using perceptron. And weights, for that, what is the weight? See, these kind of questions can be asked in exam. Okay, for AND gate, two input AND gate, design a perceptron. Design a perceptron means input you know, output you know. The only thing is you have to come up with some weights. Okay, you have to find out what weights, for what weights you'll get the required output. Okay, AND gate means two input units, one hidden unit. Hidden unit is also not required, one output unit. Okay, uh, so AND gate. If you want, I will explain that example. Okay, very simple one. Or in textbook it is there. You can refer to it. Yeah. Then, as I said, weight. The most important thing in any neural network is assigning the weight. How you are going to decide what weight should be added. Uh, See, weight update, perceptron training rule, weight WI is equal to WI plus triangle. This indicates change in weight. Okay, what is that change in weight? Change in weight is nothing but, okay, this is the learning rate, new. Okay, the symbol in neural network, wherever you say, that means it's a learning rate. It should be constant value from 0 to 1. Any values you can assign to this new. Okay, T indicates target output. O indicates actual output. Okay, we have to update the weight of each and every unit. Okay, we have to update the weight. So new weight is equal to old weight plus change in weight. What is change in weight? Change in weight is nothing but new target output minus actual output, whatever output you have generated into that particular input. So this will give us the new weight. That new weight you have to add it to the previous weight, and weight will be updated. This is how we do weight updation in case of neural network. Okay, particularly in case of perceptron. So this weight update, it follows, uh, we say that it follows a gradient descent approach for the weight updation. Perceptron unit, when we say that weight update, it follows a gradient descent approach. In the next class, I will explain you what is gradient descent. Okay, this derivation, and it is again gradient descent. They will ask in exam. One question is for sure on this. They will ask gradient descent algorithm, or they will ask one more algorithm, stochastic gradient descent algorithm. Okay, these two things I will explain in next class. Okay, along with sigmoid unit. Then we shall talk about multi-layer neural network. Okay, again, which consists of sigmoid units. Is it clear? Uh, One more important topic in this neural network is backpropagation algorithm. And this is the algorithm which we use to update the weights in neural network. Okay, very common question. You can expect a question here also. And few derivations are there. On these derivations also, very often they have asked in the exam. Okay, simple mathematical differentiation derivations. Is it clear? Okay. From gradient descent, we shall continue in the next class. Thank you.